Alright, hello everyone, this is Mr. Crozier, and I'm going to go through some review problems here. Number one, I'm going to integrate this, and I can write it as x minus 5 to the 1/2. And I don't have to worry about u substitution. I don't have to worry about chain rule because the derivative of this is just 1. So I can simply add 1, divide by it, and be done. However, on number 2, the composite function, this inside function, is now 5x minus 3. The derivative is 5. And I do have to worry about this chain rule of 1/5. And when I take the derivative, it's 5. When I integrate it, I'm dividing by 5. So it's kind of like the chain rule in reverse. So now I can add 1, divide, and you'll notice that this looks an awful lot like this up here, except I have to account for this 1/5 because that's the chain rule in reverse. And now I go ahead and multiply, turns here. Number 3, the function is the integral from 3 to 8. So from 3 to 8, here's 3 to 8, I have two geometric shapes, a square and a trapezoid, and this says sum up all the rectangles, find the area. I came up with 20.5. This crazy notation down here means composite function. What is the derivative of a function inside of another function? Well, I take the derivative of the outside, leave the inside alone, times the derivative of the inside. That is the straight chain rule. All right, number 5, a graph is shown here. Sketch a possible graph of f. So I have the derivative. This red line is a derivative. Now, if I want to sketch the possible matching function, well, at this point right here, the slope, which is this whole graph as a slope, is 0. So there's a tangent line there. And if you look at these 3 graphs I've drawn, they all have a tangent of 0. However, on the right side, the slope is above the x-axis, so these are all positive values here, which means left of this line, the graph is going up, and that's what I've shown here. Up, up, up. Now to the right of this line, these are all negative values. So down, down, down. This line goes positive up to 0, down, negative. That's how you have to see this graph. Right here in the middle is a 0 slope. Positive numbers, 0, negative. The parabolas are the graph of f. The red line is the graph of f prime. And if another way to see this, if you look at this line, it's a downward sloping line. So let's say it's negative x. If I were to integrate that, I would be back to x squared, which is the second power. So this is a parabola upside down, which is an upside down line for the derivative. All right, number 6. Well, we have a second fundamental theorem of calculus that says, hey, if you have this function right here, take the derivative. Well, if I take the derivative of f of x, well, that's f prime of x. And watch what happens over here. Just think about this for a second. If I take this function and I integrate it and then I differentiate it, remember our 2 lines here. We can differentiate stuff. We can integrate stuff going forwards and backwards. Inputs to outputs. Now what happens if I integrate something then differentiate it? Integrate to differentiation. You're back to where you started. So these kind of undo each other, and it is as simple as taking this x and replacing it with where the t is. You don't have to worry about this constant because it's kind of like a constant of integration, and that's all you have to do. And it is that simple. They look kind of tricky at first, but they're very, very simple problems when we have an x here. All right, well, what if we don't have an x here? What if we have 5x squared or 5x cubed? Well, same thing. Take the derivative is here. The derivative knocks that away. And in here, I just put my x value, which is 5x cubed. Square that, 25x to the 6. But then again, don't forget chain rule. We always have to do the chain rule because you're taking the derivative of something. So you can just do the chain rule and just write it out front. Did we do the chain rule here? Yes. What's the derivative of x? Times 1. What's the derivative here? 15x squared. So it is that simple. It is a matter of what happens when you integrate something, then you differentiate it, you're kind of back to where you started. And that's going to be helpful in this video problems that you do. All right, so here we have a function. We have f of x is this function, and h of x is its derivative. So do f of 4. Well, I'm going to use this function right here. Well, 2 to 4, integrate it. I'm sure you can do the math or use your calculator. And we have 118 over 3. But now what if I need to do h prime? Well, what is h prime? H is the derivative of this. So I need to take the derivative of this. Well, what's the derivative here? The derivative of f of x is f prime of x. What's the derivative of here? Well, the derivative knocks that out. X goes there, and it's 2x, 2x squared plus 1. I have the wrong number here for you. 2x squared plus 1. We're just going to keep it exactly the same. So now that's the derivative. That's h. H of 3. What am I doing here? H of 1. If I plug in 1, I have 1 squared is 1, times 2 is 2, plus 1 is 3. I did have the right answer. I just forgot to put that little 2 up there for the squared. But it is that simple. It's just taking the derivative because we need h, and h is this derivative. So I need to take the derivative of this thing. X goes there, and then I tack on the chain rule of x, which is just 1. Don't worry about it. And now I have a function for h. H is this thing right here. I can plug in 1, and I'm done. All right, this should help you with the rest of this worksheet.